Okay, so for part 3 of this activity, they're going to use pipe cleaners, and so each group needs a set of 7 different colors. Now I realize I don't have 7 different colors here. I don't know where ours went, but find that they need 7 different colors, and we're gonna reuse these, so we don't need a ton. So encourage the students to disassemble their pipe cleaner tree when they're done, and we'll have some extras in case they get all gnarled and gangly. So they're going to use their 7 pipe cleaners, and they're going to make each one represent one of the runners on the tree. So basically they're just building a 3D model of this tree. Okay, so the most important thing that students don't get is, and just demonstrate this for them, that at the beginning they were all one species, right? So we're going to twist them all together at the beginning. Okay, and then when one branches off, there he goes, and then the rest, you need to give them a few more twists. They ran together for a while. And then another one branches off, and then they ran together for a while, okay? And then they're going to label them using just little white strips that the lab tech will cut out for you, and they're going to write down the traits on the tree, and then they're just going to use some Scotch tape and just wrap it around and tape it. And hopefully we can find enough packets that everybody can actually do, and maybe we'll just do that and not reuse them, because they do kind of get messy with the tape. Okay, and so they're going to wrap it around and they're going to tape it. All right, and they're going to come up with a 3D model. Now, give them time to do that and to answer questions 1, 2, and 3 there on part 3. All right, and what they'll do, and so you're going to be walking around helping them, but what you'll notice, so number 1 says, and I'm going to use my tree on the board rather than this because it's sort of hard to see on a camera, but what number 1 says is a gecko more closely related to a salamander or a cow. So we're talking about the gecko, and we're wondering if it's more closely related to the salamander or to the cow. Now, the way that I have this tree drawn, if they're going by how far apart it is, they might say cow rather than salamander. But if the salamander on their tree was down here, they might say salamander over cow. Okay, and that's just based on reading the tips, is what we call it, being close together. That's wrong. We should not read the tips. The second way they might do it is by saying, well, a gecko and a salamander look very similar, so obviously a gecko and a salamander are more closely related than a gecko and a cow. So that's judging based on similarity, also a wrong way of doing it. So what you want to do is solicit people's responses so that you can point out misconceptions. Wait, how did you get to that answer? So anyone who says that it's more closely related to a salamander, you want to ask them why they said that. And if they said, well, it's because it's closer, it's one step closer, they're reading the tips or they're counting the nodes, or if it looks more like a gecko, that's also a wrong way to do it. But using the tree, what they'll do is they'll take the gecko and they'll trace it back to a common ancestor. And we can do it on this tree here. So we take the gecko and we trace them back. We're wondering about gecko, salamander, and cow. So let's do gecko and cow. Let's do gecko and cow. So if we trace them back to their most common ancestor, most recent common ancestor, it's right here. Okay. If we do gecko and salamander and we trace them back to where they diverge from each other, it's back here. And so that means this one is a more recent common ancestor than this one. And so the gecko is more closely related to the cow than it is to the salamander. And how do you know? You look for the most recent common ancestor. Okay, so we're looking at common ancestors. That's the correct way to read a tree. Not to look at the tips, not to look at their physical similarities, not to count how many traits there were. It's to look at those divergence points, those nodes, and find the most recent common ancestor. And the more recent the common ancestor, the closer related they are. Okay, the second one, same kind of question. Is a crocodile more closely related to a human or a cow? So we're going to do that one. So let's erase this, these little ones. So we're going to try to figure out a crocodile. Is it more closely related to a human or a cow? So let's look at the crocodile, right here, and we're going to find the common ancestor with the human. So we're going to go back, trace it back, it's right here. And then we're going to do it with the cow. Trace it back, it's right there. Right? So it's the same most recent common ancestor for a crocodile, or for a human and for a cow with a crocodile. So the answer is that they're equally related. And students love to say that the crocodile is more closely related to the human because the cow has one extra trait. Okay, remind them you cannot count traits. Why can't you count traits? Because there's 1,000, 100,000 million more traits I could map on this tree that are not there. The traits are arbitrary. The traits don't mean that that's the only thing that's changed between a crocodile and a cow, because certainly a rumen is not the only thing that's changed between a crocodile and a cow. Okay, and there's a million traits we could map on right here. So do not count traits. You, again, go back to the common ancestor, and if they share the most recent common ancestor, then they are equally related. This is tough for students, so you might ask another one and try to solicit more. Okay, so who's more closely related to the gecko? The human or the cow? Or the who's more closely related to the gecko, the crocodile or the pigeon? Right, so they're going to follow it back. Most recent common ancestors right here. Both the crocodile and pigeons share the same most recent common ancestor with the gecko. So they are equally related. Okay. And then number 3 says, if scientists discover a new species that has a vertebral column, it has 4 limbs, it has an amniotic egg and lungs, so lungs, amniotic egg, where would you place it on your tree? Okay, so they should be doing it with their pipe cleaner tree. But looking at this, where would you place it? Well, it's going to come out somewhere right here, our new species. It's going to come off this same common ancestor. Okay, so we'll have another one out here somewhere, whatever this one is, our mystery species. All right, and the question is, does adding that species change the relationships on the tree? Does that all of a sudden make this guy more closely related to the gecko than the human and the cow? The answer is no, right? Because if we trace them back, that's still the most recent common ancestor of all of them. So adding more species, that's the beauty of a phylogenetic tree, is adding more species into our analysis does not change the relationships that are already there. Adding different traits, on the other hand, depending on what traits you choose, it may change the relationship. So the best solution to that is to use all the traits we possibly can so that we get consensus on the tree. And we'll go into that in lecture, so don't worry about that too much in lab. But adding new species to the tree does not change the relationships on the tree. All right, so I think that's it. The next thing I'm going to do is the homework, but I want to make sure I've covered all the objectives for this lab.